Today we're going to be factoring four terms by grouping, and our objective is that we will be able to factor a polynomial with four terms by grouping. So, step 1, factor out the GCF if possible. That means that there's a greatest common factor for all four terms. After we've done that, we're going to group the first two terms and the second two terms using parentheses. Then we're going to factor out the GCF from each group. The GCF from each pair comes together to make one factor, and then the matching parentheses is the other factor. So, since x cubed doesn't have a coefficient, and the 6 doesn't have an x, there is no GCF for the entire polynomial. So we're going to group the first two and group the second two. We're going to factor out the GCF from each pair. So in our first pair, the greatest common factor would be x squared. And when we factor that out, we'd be left with x plus 2. Our second pair has a greatest common factor of 3, so positive 3. And when I factor that out, I'm left with x plus 2. These parentheses match. They must match in order for this process to work. If they don't match, double check what you used as your GCF. There might be a greater factor. So our GCF from each pair becomes one of our factors. So x squared plus 3, and then x plus 2 is our other factor. So again, this x doesn't have a coefficient, and this 5 doesn't have an x, so there is no greatest common factor for all four terms. So group the first two, group the second two. The greatest common factor for the first pair would be 5x squared, leaving us with x plus 5. It appears that x and 5 don't have a greatest common factor, but remember, everything's divisible by a factor of 1. So if there's nothing else that you can factor out, you can always factor out a 1. So then our factors would be 5x squared plus 1 and x plus 5. All right, so in number 3, we don't have a greatest common factor for all four terms. So I'm going to group the first two, group the second two. The first two have a greatest common factor of x squared. And when I factor that out, I'm left with x plus 4. Now when I'm looking at my second two terms, notice that they're both negative. And I know that my parentheses have to match, and these are both positive. That's a hint that I have to factor out a negative number. 9 is the greatest common factor that goes into both of those, and if I factor out a negative 9, I would be left with x plus 4. My greatest common factors create one factor. My matching parentheses is the other factor. Now, if you're in FADA, you're in one of the FADA classes, stop here and go ahead and fast forward to problem number 4. This is where you would stop. However, if you're in Algebra 2, we've learned about difference of perfect squares, which is what x squared minus 9 is. So we know that that can be factored further into x minus 3 and x plus 3, and then I would bring down my factor of x plus 4. So again, if you're in FOD, I would expect you to stop here. If you're in Algebra 2, you would keep going with factoring the difference of perfect squares. Now, in our final example, if you notice, we have a 4, a 4, a 6, and a 6. Well, those are all divisible by 2, so I'm going to factor that out. Once I've done that, I'm going to sort of ignore that greatest common factor. Let me hide it. I'm going to ignore that for a while. I'm going to pretend it's not there, and we'll come back to it in a little while. So I'm going to group my first two terms and my second two terms like we've been doing. The first two have a 2x squared in common, leaving us with x plus 1. Our second two terms have a 3 in common, which when we factor that out also leaves us with an x plus 1. So our factors would be 2x squared plus 3 times x plus 1. Now that we've done that, we're going to bring our greatest common factor back in. So I'm going to bring it down in every single step. So 2, and then I'm going to put parentheses around this whole thing. And then since the last two, the last step, they're already in parentheses, I can just put the 2 in front. I don't need another set of parentheses. That's all for today. See you in class.